Alright, so a long time ago, we're at 5-4. We learned about division. And back in the day, do you remember doing division, getting remainders? Right? And then later in life, you learned about the joy of decimals, right? So we are going to be doing long division today with polynomials. And we are going to get remainders, okay? And then we're going to take those remainders and put them on top of what we divided. Good news and great news. I told some people this already, everybody actually. We're not going to do a lot of long division here. I'm going to do one problem with you guys, and then that's the last we're going to see of it, okay? Is that okay with you guys? If anyone wants more, you can always watch the other video as well. So when you do long division, we're going to set up our x minus 2. How many times does that go into this piece right here? X to the third plus 5x squared minus 8x minus 10, right? I'd have this as a reference. Now, when I'm doing anything with polynomials, what do I care about the most? Like if I want to know end behavior, if I want to know how it acts, what do I care about? The leading powers. So when you long divide, you always look at your highest power on both sides. Okay. How many times does x go into x cubed? What do I have to multiply by x to get x cubed? X squared. And then just like I did over here, I did 1 times 6 is 6, right? And I subtracted it. So I do x squared times this is x cubed minus 2x squared, right? And then I'm going to subtract it, so I'm going to change all my signs. Because I need that to cancel. That becomes 7x squared. And then when you did division over here, what did I do with the 2? Brought it down, right? So I'm going to bring down the negative 8x. And I do it again. What do I multiply x by to get 7x squared? 7x, right? 7x times x is 7x squared. 7x times negative 2 is negative 14x. Change all my signs, and I'll leave it just fine. That's going to cancel. Negative 8 plus 14 is 6x. Bring down the 10, and we'll do it again. Sorry guys, this is like becoming Miss Rachel. I should make that like the Miss Rachel of the college mathematics world.
Yeah, you should put a theme song on here.
Blippy. What do I times x by to get 6x? Well, 6x, or 6, of course. 6 times x is 6x. 6 times negative 2 is negative 12. Change all my signs. I get 2. Remainder 2. Ta-da! Alright, so honestly, it's not extremely difficult to do this. It's just, how many chances do you have to make little mistakes here? A lot. And if you make one little mistake, it happens to the whole problem. It just spirals out of control. And actually, if you really want to be cool, you could do plus 2 over x minus 2. We'll talk about that later. You take your remainder and you put it over there, because it doesn't evenly divide, right? My last step would be to divide those. I don't know if that's what you did earlier, or if you just put remainder. In here, we're mostly just going to say, hey, what's the remainder? But if you move on sometime, you're going to want to be able to know how to finish the polynomial. Here's a question for you. It's a prelude. Do you think 2 is a 0 of that top function then? Do you think 2 is a 0 of this top function? I would say no. Because I got a remainder. If 2 was a 0, when I divide it, shouldn't it divide out evenly? No remainder? Ah, that's what we're going to do next week. Alright. Are we good with long division? Alright, let's do the fake one. It lasts longer in your car anyways. Synthetic oil? Did it? No? Okay. Alright, so synthetic division only works if you have a power of 1, a linear, you're dividing by a linear function, right? So that's why long division is still taught, is because it doesn't work when you have more to it. But luckily for us, everything we're going to do, we only need to divide by a linear, so that's okay. I don't really care for this diagram very much, but it is the rule, right? You're done. You bring it down. Let's just do examples for them. It makes more sense with examples. All right. So divide using synthetic division. Few quick things we need to know when we divide by synthetic division. Number 1, all that's going to matter to us is leading coefficients, and then number 2, the rule for synthetic division only works is if you divide by x minus r. You put r up here, okay? That's what the other slide was saying. So what do I always have to do with my sign of the bottom? Flip it. You always have to flip it. Yeah. So the first thing I'm going to do is I'm going to set up my little box over here. I'm going to put a -3 in it. Good catch. And I got it from the bottom. What am I dividing by? Okay. That's step uno. Okay. The next thing I'm going to do is I'm going to take all my leading coefficients and just list them across the top. So I have a 1, a 1, a -3, a 4, and a -5, right? Any questions where I got any of those? Taking our hit coffee. Line. It's more crooked than a dog's hind leg, but that's okay. Now, if I look back, you guys have on your sheet. The first thing. What's a good color that stands out? First thing I gotta do is move that 1 down, right? And that will always work because you're dividing by 1 in front of your x. You can't do this if you're dividing by like 2x minus r. You can't, we're not gonna, so we're gonna move the 1 down. And then what do? I multiply the 1 by the -3. So here I'm gonna do 1 times -3. Right? And what's 1 times -3? I need to write that over here a second. So I got -3 down here, right? What kind of problem is this set up like that you saw a long time ago in your life? Remember back in the day when you'd be like, what's 3 plus 4? So yeah, what's 1 minus 3? -2. Okay? Then what do I do with that -2? Multiply. So then over here I'm going to do -3 times -2, right? That -2 came from here. 3 came from there. There's a lot of arrows here. It's funny. This looks like one of Mr. Shelton's plays. Sorry. More like someone else. All right. So what's -3 plus 6? 3. What do I do with that 3? Multiply by that. -3 times 3 is -9. 4 minus 9 is -5. What do I do with the -5? multiplied by, it's always this -3, right? Everything's gonna get multiplied besides the first by the -3. So what's that, 15? 15 plus -5 is 10. Okay? Now I don't know how you guys have ever learned this before, but I put that bar there. The last term is your remainder. The last term is your remainder. This is your remainder. So that's why I always kind of separate out. It's his own thing. It doesn't get to play with the other polynomial. It's a bad kid. Alright. So then, in reverse order, or what I do is, the -5 is going to be my constant, and then I add an x squared, x to the third, right? As far as I need to go. So the answer to this problem is x to the third minus 2x squared plus 3x minus 5, remainder x. Okay? Again, if you've done this before, you know the more you do of these, you can rip through these really fast, right? Let's do another one. I'm gonna do one more. I'll have you guys try one. We'll go over it, and then I'll have one more thing. And that's actually it for 5-4.
That's it.
That's it. Because I'm skipping a lot of the long division. I mean, we can do more long division if you guys want
Where's
to.
your banana?
No. I mean, if you want to, though. For fun, we put the fun back into fiction. Spend our time number crunching. This time I'm going to use just one color. What? Bro. Alright. Help me out. What number am I going to put up here in my box? 2. Positive 2, because that's negative. Now be careful. This one has a trick to it. It's trying to get you. Don't write this, but the most common thing I'm going to see on this problem is this. And then you're going to say, Mr. Earl, I don't know why it keeps telling me my answer's wrong and the polynomial doesn't fit. Why is this not that? X to the 4th.
There you go.
I have to list every one from 5 down. So what is, if I don't see an x to the 4th, what is the coefficient? 0. Yup. That is the #1 mistake made on these, because you get into autopilot, you're just having the time of your life, and you're sitting there, you're drinking your Alani, you're just doing some college algebra, and then you just forget everything about polynomials.
Yeah.
Is that a true story?
Heck no.
Alright. Alright. First step every time, all the time. I have nothing to multiply that 2 by, so I gotta bring down a 1. Bring down that 1. So I'm gonna do 1 times 2, right? 1 times 2 is 2. Add them up. 2. 2 times 2 is 4.
Yep.
Add them up. 2 times 3 is 6. 2 plus 6 is 8. 2 times 8 is 16. 16 minus 4 is 12. And then 2 times 12 is 24. Ew. Ew. Put a bar there. Alright. Am I done? That looks like just some crazy stuff up there. Constant x squared, x to the 3rd, x to the 4th. Quick way check. This was x to the 5th, right? When I divide it, I should get 1 less, right? My polynomial should be 1 degree less. And then this is my remainder. Now let's put the pluses. There you go. Oh, whoa. Kind of include that guy counts. What do you need to do with that 33 if they're asking you for a remainder? They want the polynomial. What do you have to? Actually, it's not even polynomial. But what do you do with it? You convert that 33 to 33 over
2.
x minus 2. Yeah. All right. Go ahead and try this one on your own, and then we'll go. I'll just go over it, see how you did. If you're watching the video, pause it. Give this one a shot. Give it a shot, and then if you can do this, you're actually gonna be really good for 5-4. All right, how'd it go when you did this? What made this one different than all the other examples we saw?
No remainder.
No remainder. So now think about this. Do you think 2 is a 0 of that function?
Sure.
Yeah, because I can factor out x minus 2. So that's what the whole next section is about. Is pretty much, if we know a factor, we can divide it out of it using synthetic division. The only other thing for this one you're going to see come up is this. And this is something interesting. So we divided out all these problems, right? Did we divide this by x minus 2? This was our second example, right? Let's see something neato. Let's plug 2 into this function like they want us to. This is some magic stuff going on. Right? So I'm going to plug that in and figure out what's 2 to the 5th. 16, 32, right? Right? Sorry, I'm just doing this. Let me know if I did anything wrong here. I did it really quick. What do you guys get for that? I got, what, 31 or 33? What was the remainder of our second example when we divided by x minus 2? What was the remainder? 33. Wait a second. This was the same as our remainder? That's interesting.
Yes.
When you divided this one by x minus 2, what was your remainder? 0, right? So what's going to happen when we plug in 2 to this function? Jeez, Louise, this is a lot, right? Oh, man. No, wait, I got 0. I got 0. So you're telling me that if I divide a function by the linear, the factor of it, that I'll get what it is when I plug in that function? Yeah, because when you divide out, if it's a 0 and I divide it out, I should get a 0 because that is a 0. That's called the remainder theorem. And they want me to do it again. Here, we'll say this. So, I should erase that. If I divide it out and I get a remainder of 0, right? Then whatever I divided by is a factor of it. Okay? With that also being said, could I test before I divide something out? Well, honestly, synthetic division is less work than plugging the number into the function. Would you agree that with like the x to the 5th one? Synthetic division, the math is easier. Like I can do it really quickly. So could I actually go through, and if I had a really big polynomial, use division to find out what the value of something is at a point? You can. Also, you can use it to test if there's a factor before you need to do it. So there we go. That's called the remainder theorem. Okay? And with the remainder of our time, what I really, really want to do is just give you the first few slides of 5 so that next week we have more time.
You.
Yeah? Yeah?
We're way past that.
I don't know if I fight five, don't matter. Oh no, it's 5-6. Back in my day. Maybe I have it. This is exciting television for the people watching out there.
But
That's not a decision to make.
I'm gonna tell Miss Mac to ask him. If it's worth going to. No.
Alright, so this is a continuation. This actually goes hand in hand with what we just learned. This is why I want to do it right now. And if we do this right now, next week, we can probably get by with 2 lectures and more work time. Alright,
Not
so,
switching stuff up.
hey, we just talked about this. Is this about where the glare is?
No. Oh wait, yeah.
Alright.
Yeah.
So, a 0 of a polynomial is such that half of that number is 0. You agree on that? We call that a lot of things. We've called it an x-intercept, we can call it a 0, and now we're going to add another term. We can call it a root. Okay? A root because that's where it hits the ground, right? That's why it's called that. I don't know. I just made it up. It sounds
Is
really
it
good.
root or root?
A root? I'm from root. I'm from root.
No, Matt's from root.
You're from root. No, you're on the north side. You're at Hard Beach. You're fake. You're fake root. All right. So again, if half of that number is 0, it means that that's 0 x-intercept. Could I find this from looking at the graph? Yeah. Based on this graph, what are my zeros? Is this a 0? Yeah. Is this a 0? Yeah. And that's my 0, right? So from the graph, I know I have -3, 0, 1, 0, and 2, 0. So those are my zeros, my roots, my x-intercepts. They all mean the same thing. Okay. Hey, what degree would this polynomial be, do you think? What power is it being taken to? At least the third. At least third. Could it actually be the 5th? It could, but we know it's not even. Alright. So, dude, this definition stuff drives me bonkers sometimes. If I have a polynomial to the power n, it means I can factor into n parts. Okay. That's good stuff. But I've only done one so far. Alright. So, have you guys ever heard the term multiplicity?
Yeah.
What's multiplicity mean?
I don't know.
How many times something happens in this multiplicity, right? So like the multiplicity of the times I hear 6, 7 in a day is about 1,256.
Wait, you say you hear what?
Here the number 6 preceded by the number 7.
Still counts.
Alright. So a multiplicity is how many times do I hit that 0? So like for this one, we have a 0 at where? Where are my zeros? We have 4 of them. I have a 0 at what? 3? 0, right? How many times do I hit that 0? What's the power of it? 2. So what's the multiplicity of that 0? Multiplicity is 2. This is a 0 at 6, 0, or x equals 6. How many times do I hit that 0? 4. This 0 is -2, 0. How many times do I hit that one? Once. And this one I have 11. You don't have to write the points every time. And that's a multiplicity of 1. How's that? That's not too bad, right? We can do that. What's my 0 of this one? -4. And what's my multiplicity of it? 1, right? There's only power 1. This would be 1. X equals, do they want the actual points? X equals 1. Multiplicity of what? 5. This one's not going to be on the graph, right? Correct? So, I'll make sure. So what would my 0 be? What number would make this 0? What complex number? What do I do with both my signs? Like over here I did -4, I did +1. What do I do with both my signs? Yeah, I'll flip both of them. So that'd be -2 plus 4i. I'm not going to put that one on the graph because it's not on the graph. And then -2 minus 4i. It'd be 1x equals them. Both have a multiplicity of 1. Then I have the 0.70 with a multiplicity of 3. How's that? That too bad? Alright, so let's start 5, 6, 7.